Hello, welcome. This is Birdy. Welcome to a new lesson in Houdini. Today we continue our series Advanced RBD Constraint for building destruction in Houdini. Today we'll create the smoke simulation by using the sparse pillow smoke from the shelf tool, and we will explain different techniques. So let's get started. So now let's continue. Let's add the smoke. Okay. First of all, I think I will add I will use the shelf tool, the spore pillow smoke. Doesn't really matter the area. Maybe you can check it from here. The problem about the spores pillow, it doesn't select any object. It only selects smoke. Not like pyro. You can select an object to emit smoke from it. It's different. To be honest, I still I don't know why, but it is what it is for now. Maybe I'll know the reason later. Okay, so now we have here by default it creates for us a sphere. Okay, so we don't need the sphere. There is actually two ways to do this by adding the building itself, or by the in another way the inside edge, or just to add the particles. Okay, so I think I will add the particles, but first of all I have to select the particles. Here is the particles. Here's the file cache. I will use this one, looks better. So I will simply add this out debris. Okay, let's go back. Maybe I give this one a red color too. So let's get inside this one. No, here I will add object merge, and I will add I think it was in the debris. Where is the debris? Debris. Okay. Now debris. So I have the particle here. We can simply add it like this. Okay, but it wouldn't work because here it's the mode is volume scatter. We have to change it to keep input, so it will keep our particle from this one. Okay, of course it will take time because it convert it to a volume. That's why it takes time, but we are almost there. 6 from 6. Okay, yeah, as you can see here. Oh, I will hit escape this time. As we can see here, looks nice, looks really nice, but we need to make some modification. Okay, first let's delete this one. First we need to control the density. We have here density, as we can see, density and temperature. We need to control the density. So we'll add attribute. There are many ways to do it. I will show you two methods. First one is by attribute triangular. We will type a simple code. We will add sorry add let's say scale. Let's mean temperature density underscore, let's say scale equal fit range we will control it by the age. We have age, we have a channel. Let's make a channel minimum, channel maximum, and let's type 1 then 0. Sorry, 1 then 0. Okay, we need to add the channel here, 2 channel. Let's add this minimum underscore scale, and this one will be between 2 brackets max. What is going on? Max underscore scale. Okay, hit this one. Now we can control it, but first we have to see it first. I think this is the smoke itself. I don't need to see the smoke now, so I will simply hide other objects. Okay, so let's say it started from 0 to 1, meaning at the beginning of the age it will have a maximum scale, meaning it we will multiply it in the density, meaning at the beginning of the particles emit at its first age, at its born, it will have a complete density. Then by time it will fade to 0. Okay, so as long as the particle lives, as long as it will die faster. Okay, so maybe we can see it here. We have density scale. Yes, maybe we can change this one to something we can understand. I will leave it as auto. Maybe I will make it white to black. Okay, so sorry, my cat playing with my mic. Sorry about that. They like to sit on my leg while I'm working. Okay, it's a very cute cat. Okay, so where was we? Here, yes. So as you can see, first it's a white, then it goes to black. I think I need to make it different. This is white and this is black. The beginning white, then black. Okay, so maybe I will make it live a little longer, not dying very fast. Yes, maybe something like this. Okay, so this is the first time. This is the first thing. Second thing, we also might have a benefit from the velocity itself as well. So we will use the velocity, but this time I will change this one to, let's say, I will name this speed, and this one I will change this one. Instead of age, I will use the speed. We can have it from the velocity, meaning we will compute the length of the velocity like this at v small, of course. Okay, so we will have as well, but of course we will change this one to speed and this one to speed, but instead we will make it from 0 to 1. It's different, so as much as the particle is very fast, it will have a complete density, and when it started to be slow, the density will become much weaker. Okay, maybe we can check it as well from here, but first we have to, let's make it from 2 to 4. Okay, or maybe from 1 to 2 first, just to see it. Let's see it. Speed scale, yes. I'll change this one to for it, yes. So the as we can see here, the warm color is the fast, and the blue is the still doesn't move. Okay, maybe I will make it from 2 to 4. Maybe something like this, or you know what, from 2 to 3 maybe. Okay, so let's now add the density, what we wanted to do. Density multiply equal this one multiply by this one. Actually it will be 8. Okay. So if you want to check the density now, we can check the density here. Density. So here is the density. Okay. We can also control it by the infrared. So the warm is the big density, the blue is fading density. Okay, we can check it from here as well if we want, because here it's, yeah, you can see. So first of all, let's hit the velocity blur, and let's make this one, let's stretch it in the direction of its velocity. Let me cancel this one for a moment. Not much. We have element size, police duration. Okay, looks good. I'm gonna change it. So this will be this is the first method. Okay, the second method, let's add a trial from these particles, and maybe I will add 6, and then let's add trial, let's add to add a line or geometry. So let's go to the polygon by group. Of course it connects everything, but we will connect by attribute, and we will type ID, because every particle has an ID, so that's why it track its ID, and it make line only with the same point that has the same ID. So as we can see here now, if you want to make this trial bigger, we can make it 8. Okay, this is first. Second, let's add resample, because if we check it here, we'll find that it doesn't really give us what we want. So maybe I will add resample to resample the point again. As we can see now, we have, I think, a better distribution. example, if I can increase it more, and I add it more and more particle, as we can see here. But you know what, I will leave it for just 0.1 for now. So this is for second. We will need this one. Control this, Alt, change it here. And let's see what we have so far. Okay, so this is create, add noise, add. Yeah, okay. Not sure if it's, yeah, there's a huge difference. As we can see here now, it gives us much more uh, smoke. But for the density, we need to control the density. We need to make the density at the beginning is strong. Then after it started to get old, it become much weaker. Same at the age, but it's this concept almost same as the age. But by age we type it by code, and but by this method we make it by node sub node. Okay, sub level, in the sub level node. Okay, so let's add UV texture, and we will add row and column. I will add it to the points. Of course we cannot see it, but if we check the UV, yeah, we can see it now. We need to change this one, maybe attribute swap. Attribute wop or attribute wrangler, both will work. I think we have the UV here. Yes, we will add it to fit, maybe fit range, if you want, or let's add it to the color. See it here. Of course, it gives us the same result. But I will take, I think, vector. Let me see, vector to float. Yeah, 0 to 1, 0 to 1. Yeah, okay. Yes, as you can see here, perfect. It works. I think it works with the boss 3. No, it only works with the X. Okay, and this is more than enough. We can control it here by, if we want, 0 by now. 1, 1, 2, 0, as we can see. And also we can ramp it. Spline ramp. Of course, it gives us black because we don't have here. Now we can control it like this, maybe like this. Even we can switch it, as you can see. So we can do whatever we want. Okay. So now the color, we will multiply it in the density. So I will add attribute triangular. And I maybe add density multiply equal C at cd dot x, for example. So if we check it here now, this is before, this is after, and this is before and after. Yes, okay. So it killed a little of it, but it looks nice. You can see here. Not sure why it gave us, an error here. Because maybe we don't have an 8. Yeah, I'll leave it as a 7. Yeah, because here it must be. Yeah, okay, no problem. So maybe I will make this from 1 to 8. Something like this, maybe. Yeah, okay, works just fine. So this will be 0 density. I'm not sure which one shall we do it, this one or this side, not sure. Yeah, so I think I will invert it. So as we can see here, now we have the actually, it's really tricky. I think I will leave it as it is, like this. Okay, so now we can even add this one. We can depend on this one in our simulation, or we can use this one, or even we can maybe I will leave this one instead. Okay, so even we can add this one still. I think this one. Yeah, I think this one to this one if you want. By there are two ways. First, just add this here simply like this. Okay. So it will change everything, but it will still working. Okay. Yeah, but I think we have to multiply by at cd.x. Density equals cd. Yeah, I think it should work. Yeah, I think it's already work. This is one way. Another way is simply just to add attribute copy, just like this. This one, this one, and simply attribute permission. Yeah, copy. Yeah. But I think it doesn't look like it's working like that. Attribute copy. I'm sorry, attribute transform. Yeah. No, it's attribute copy. Anyway, we can use this one instead, like this. Okay. So really, it depends on the look that we are seeking. Okay. Maybe we will use the three of them: the CD, this is the copy. Yeah. Okay. So this will be the density that we are using, and we can check this one. Maybe nothing much different, not much different. Mhm. So now let's check the smoke simulation to see what we can do about it. Let's get inside it. Okay, let's check. Of course, we can do all this from scratch, but since Shelf Tool is making a great job, so I think it's no need to do lots of things. Okay, temperature, actually I don't need a temperature, so I'll simply make it one. Don't need much temperature. Also, we don't have a velocity here, so we need a velocity. So let's make a velocity, and I will separate it. I can add it here, velocity, but I will separate it to another source density like this. Of course, there is source volume. I'm sorry, volume source. Of course, there are many by default. Some of parameter need to be checked, but when we use a shelf tool, it check it. For example, like in large fields to contain source and all this stuff, it's make it by its own. So let's make another one, volume source. Okay, it takes time. I think okay. I think I will be at frame 1. Go back. So let's go back to the smoke source. Density. Okay, we have the velocity as we can see here. So all we have to do just copy and paste this one, Alt, hit Alt to drag it and make another copy. Okay. This one will be for only velocity, and of course velocity is a 3D. Don't forget to change this one. Okay, so we will change the velocity that it came already. We will add to it some noise. Okay, then we will type here V, and we will leave everything as the same, but just this one we will change it to well. Okay, so if we go to the smoke simulation, we can choose anything and go back to the source smoke. It will already add many fields, 3 fields. We will delete the first 2 and we will leave velocity as it is. Okay, so let's check. Let's choose the, I think it's smoke. Yes, this one. Add it here, and now we have velocity. It will turn it from the source volume as V to the vel, because Houdini read it as the field read it as vel inside the dot network. Okay, so this is the first thing. Second thing, we need to do some modification. I think maybe check. Sorry about that. The cat is fighting. Okay. So I'm not going to change anything here, nothing actually to be changed, but maybe here I need to change the Y to close below. That means it will close down as if there is a collide, or I add a background. Okay, that's the only thing that I can do here. And here also, let's check shape smoke. We will add the disturb, and I will leave the dissipate as it is. Okay. So let's first add the collision, because I need to have a collide with the smoke. Okay, so I will add another volume source. I will add the volume source here to the advect. Okay, but how can we add it? First, we need to have the collide here. How can we have a collide here? Simply, I think we already have it in the debris. Not sure why it sometimes give me. Okay, so here is the collide. We need this one. Okay. We don't need this one, we will do it by ourselves. So sorry, what was its name again? Collider. Okay, so let's go back here. Let's add another one here. Object merge in the debris. Let's add the collider. Now we have the collider. Let's convert this to a VDB. So let's VDB from polygon, and make sure it is a polygon, not a packed. Let's check it. It is polygon, as we can see. It has a normal name, blah blah blah. Right? Okay, so let's continue. We need it as a VTB. We're not going to change this, but actually we need to change the name, its name. Why? Because in the smoke source we need to have a collision. There are two ways. The regular way is to add merge and add a collide, same as if you are using a deforming object. And the second way, which is much better, is to add it from the volume itself. So it has two names for the collision, as if it is a surface. This is a surface and this is collision. So we need to change it to a surface, or to copy this surface and paste it there as a surface. Okay, so let's go back here, smoke source. Okay, it will take time. This is first. Second, also we need to have the sure that we don't have the glass. Actually, I don't want to have the glass. I don't need the glass here. The glass will take lots of memory. Actually, I don't need it, so I think yeah, it should be from this one. I forget maybe to connect the light here, but anyway. So let's go back here. Okay, so this is first. As we can see now, we don't have any glasses. Of course, we will play with the voxel size, but first let's also copy the velocity. It's called V, but we can simply, okay, you know what, I will simply just copy as if it is V. I'm not going to change it. Just leave it V as it is. Point V. I will name it V. So it will read it as V. Okay, this is all I think that we need to do. Maybe last but not least, we need to have the voxel size as well. But you know what? I will control the voxel size. I think I will leave the voxel size for now. Okay, let's make this null out collision. So let's go back to the simulation, and let's choose the outlight smoke source outlight. Okay, nothing really should we change. I will leave a -y because this is a VDB, so by default they add it as if as a -y, as we can see here. Okay, this is first. I think there is something else I need to do, to go to advanced collision and uncheck the build collision mask, because we already brought our collision inside here. Okay, so last but not least, last thing, we need to copy this one, copy parameter, the voxel size. I think I will paste it here as a voxel size. Okay, paste relative preference. Yes, it will give us a much better resolution. Okay, so let's go back. I'm not sure why it's showing me this one. Yeah, because I'm, yeah, okay, something. So let's also add a merge. Let's play a little with the simulation. Let's add, if you remember, we unchecked the disturbance here. Maybe we can add it as a clip, a micro solver, because here, block size, yeah, here it's work as a block size, but we want to have a advantage of the new one. Just disturb this one. Of course, all this will go to the advection. This last one is a force. I will check the control and I will type vel. So velocity will control the field that it will have the smoke. Okay, so we can check everything here. I think let's play. Okay, so as we can see here, I will hit stop. As we can see here, the simulation is just work fine. Everything looks in its place, and it looks really. So let's get inside the smoke import, and we will do just a few steps that can make the cache for the smoke is much less in the memory. Okay, so as you can see, we have many fields. We will compress the velocity. Okay, oh, we have a flame here too. Okay, but we're not going to use it. Okay, so first of all, let's make a I think it's called reshape volume resample. Who said reshape? So first of all, we need to choose which field do we want to compress. Take time. Okay, so we need the velocity, but instead of vol.x.vol.star, so it will bring the three amigos: velocity.x, velocity.y, velocity.z. This is first. Second, let's make it 0.2. So now let's check what we have here. As we can see, the velocity only we have 20% from the original, I think. So that's so now we can see the velocity become much smaller. Okay, so this is the first step. So now let's use the blast. Let's isolate the density, delete non-select. So this is first. Second, let's add volume blur for this one, and I will make it 0.5, maybe the half. Let's make it 0.5 for now. So now let's add volume compress. This is the original. We will add this one here, and we will choose the density. I will choose the maximum 0.1. Also, let's add update compressed setting and use 16 byte float. So now it become much smaller. If we cache this one, it will be much smaller. We can cache it. We can add file cache now. Now we can save it. This post process, I don't think it. Yeah, just for review only. So now we can save this one. Let's name it file cache spores, and of course we should, when we save it, save frame range from 1 to 20, and this one will be the null. This one will be the render for out smoke. So we will. And that was it for this lesson. I hope you enjoyed. If you have any question, please type it below the video. Also, don't forget to subscribe to the channel and like it. Also, if you have any question, you can join our tier on Patreon. Ask me anything for technical support. Also, all the HIP files are available on Gumroad. And if you like, you can join our group on Facebook and share with us your works. And I see you in the next lesson. Have a good day.